Alright, real quick on this. First thing we notice is there is a bx term, so we need to get this set equal to 0. So subtract 3, add 7. A. And let's see, I'm gonna move that over there. And we'll get 15a squared and then plus 4a minus 3. Set up your star and we'll have negative 45, positive 4, and then 15. Kind of an unusual a value, but it's not a big deal. Are there factors of negative 45 that add up to positive 4? 9 and negative 5, yep. Okay, now we need to check. I didn't mention this, but we need to check if there's a GCF. There's just not one in this case. So always be looking for that though. Here we need to simplify both of these. These are both divisible by 3. And these both divisible by 5. So now we're ready to solve. This is where we do the zero product property, meaning if we're multiplying two things and it gives 0, one of them, or perhaps both, is 0. So we set each one equal to 0. There's one version. And this time I'm just going to write the result, which is positive 1/3. How'd that one go? Just want to keep this fresh. We do a lot of it in Algebra 2, and of course you've seen it already in this class. Any questions on it? Okay. If this was a geometry problem, what would you need to do next? Like I circled both of those. What would you need to do though from there? Huh?
Plug it in.
Yeah, and check to see if it works. Okay. Remember, negative results can work sometimes, so don't just throw it out. All right, distance between 2 points. This is negative 5, 1, and this is 4, 0. Midpoint. I'm just going to do the quick method, so we'll start there. Remember that midpoint splits this line in half, and it went from end to end, it went down 1. So from end to middle, it's going to go down a half. So we know that our y coordinate will be 1/2. And then from left end to right end, it went over 9. So from left end, it needs to go over 4.5, which is negative 1/2. Any questions on that? Okay, that was kind of the quick thinking method, especially since we have a graph. Distance formula, make sure you're writing it first, so you know where to plug stuff in. So x2 is 4, x1 is negative 5, and then y2 is 0, and y1 is 1. Be careful on the subtraction, so you should get 9 squared and negative 1 squared. What is negative 1 squared? It's positive 1, so our end result is square root of 82. Does that simplify? Meaning, can we split this up into 2 squares, or square roots, and have this one be square root of whole? Well, we know it's real close to 9, but we could see if 4 goes into 82. There just happens to be an 82 right there. Nope. Okay, so 4 didn't work. 6 isn't a perfect square, so it won't square root. So 4, 9 we know doesn't work because it's too close to 81. And then the next one is 16. It doesn't work. 25 doesn't work, so we're probably not going to simplify this one. How'd those go? Hold up, how many you got right? Like 1 or 2 out of these last 2 is what I mean. Do you have a question?
Is it okay to just do the decimal instead of doing simplifying?
Depends what the directions say. If it says no messy radicals, which the check mark, that square root is a radical, or I mean no messy decimal, excuse me, simplest radical form, then don't do a decimal. Yeah. If it doesn't say anything, then yes, it's okay. Alright, so yesterday we got into the world of parallel line proofs, various versions. We had two options. You're either given parallel lines and asked to prove some angle relationship, or vice versa. So, how'd those go? I'm going to check them with you here in a second, and today we're just going to look at them. We're not going to do every one of them. But is there one now that you know you'd like to do? Before we just check. Yeah.
Number
6, okay. Alright, statements and reasons. I'm going to just write the given. Remember on this particular sheet, the black, heavy black mark means parallel. It's meant to have two parallel lines there. Is this stuff marked in the picture? No. So remember, go add stuff to the picture that you're either given or know to be true. So it says CD and AB are parallel. You could put the arrow on there, but I also think it's helpful, and I think I've mentioned this, if you extend these out. So now we're really seeing these lines parallel, and I think these, like AD and AC, are jumping out better as transversals now. It also tells us angle 2 and angle 1 are congruent. That definitely needs to go in here. Would those be congruent otherwise if we weren't told that? Like, do they have a geometric reason to be parallel, or excuse me, congruent? Are they any kind of our known angles is what I'm asking. Yeah.
I would think that they were same size here.
So it's kind of tempting to think that they aren't actually that. Same side interior would be like this whole angle and that angle, or perhaps angle 1 and angle that one. So yeah, these don't actually have a reason to be congruent otherwise. Hi.
Hello, Zoe.
Now here.
All right, thank you very much.
Yep, thanks. Alright, anyway, our goal here is to prove that 2 and 3 are congruent. Do they have a reason to be congruent without proving it? Or are angles 2 and 3 any kind of special relationship? No, they're not. And it's because angle 2 is formed by two transversals, right? Meaning it's not one of the named angles that we put on our list. So what's a good, we have to figure out some way to link 2 to 3. Right now we have 2 and 1 linked. Is there a link between 1 and 3? Maybe we could say. If there was a link between 1 and 3, then we could probably bring 2 in and link it to 3. So these are the kind of questions that you should start asking. So is there a link between 1 and 3?
Alternate interior angles.
Yeah, so angle 1 is congruent to angle 3 by alternate interior angles theorem. Those of you just writing AIA, if you just write alternate interior angles, you're leaving off the actual reason why they're congruent, which is the T part. So the theorem actually tells us that they're congruent. Otherwise, we're just saying that's what they are. Okay? So I'm going to link those two now. Is it safe to say that? Like, we've seen proofs where it's not safe to say things until we prove something else. So are we okay to say this at this point? Yes, why? Do we know the lines are parallel?
Yes.
Yeah, we were told. So just make sure you know enough information to use your theorems. Okay? Well, here's what I see. 2 is 1, 1 is 3. So I can just take that and substitute it right there. And we've proven what we were asked to prove. So 3 steps. Does that help? Any others? Do you guys find it helpful to extend those parallel lines like that? Alright, so let me put up the key for the others, and it's kind of in a weird format, so. Alright, so you're looking on this left page. So we have given, and then alternate exterior angles, alternate interior angles. Both of those need the T for theorem, and then substitution. Number 2, obviously given, and then linear pair postulate, alternate interior angles theorem, and substitution. Number 3, so again, you see me extending those lines just as a visual. So step 2 is corresponding angles theorem. Sometimes it's kind of helpful to turn your whole paper if you can't see that those are corresponding angles. Sometimes that helps. Okay, angle 2 and 3 is substitution, and then this is a prove parallel. So we have to prove by converse of, and this particular one is converse of corresponding angles. How'd page 1 go? Hey, lots of thumbs up. Cool. Alright, and then 4. Number 4. Angle 1 and 5. And the parallel lines. I separated this into 2 givens this time. That's fine if you want to do it that way. Angle 1 and 3 are corresponding angles. And then 5 and 3 by substitution. That was a quick one. Number 5. This proof actually has more to it, so I'm curious to see if anybody went here, but we're asked to prove 6 and 2 are congruent, knowing that G and H are parallel, and 6 and 3 are supplementary. So here's the technical side of this proof is in red. I'm guessing you probably thought through it this way, maybe. Here's what I mean. 6 and 3 are supplementary is not an algebraic statement. That's a geometric one. So we need to switch over to algebra mode with the definition of supplementary angles. Okay? Angles 2 and 3 are supplementary. That's also a geometry statement. Same side, interior angles postulate. So that's a P, not a T. Okay, now we have to switch this geometry statement to an algebraic one, again by definitions. So we have 2 algebraic statements. Okay? Then we're going to set those equal. Like here I said angle 2 and 6 is congruent, but here's the why behind that. If we subtract out, well, we set them equal, I mean, either by transitive or substitution, and then we subtract out angle 3 to get the fact that their measures are equal. That's still algebraic mode. Then switch over to back to geometry by definition of definition of congruent angles. So the blue with the red, that's how the proof should actually look. This is kind of a shortcut for beginners. Did anybody do all that stuff in the red? Okay. So the big idea there is you can't do subtraction on congruence. Does that make sense? I do kind of want to write that statement out. Here's what I just said and what I mean by it. Like if I have angle 6 plus angle 3 is congruent to angle 3 plus angle 7. You can't do algebra on this. I can't subtract with congruence because we're not doing algebra. That's just a statement of like looking the same, being the same size. Do you get what I mean by that? So if you need to subtract or add or manipulate that way, you've got to switch over into the algebra world with definitions. To do it correctly, that's what you need to do. Okay. Alright, so I know some of you started the rest of these. I'm going to give you the rest of Well, I guess we don't have the break today, so I'm going to give you some time to work on the other 2 pages and finish this up, then we'll check and see. I think at that point I'm going to give you a little angle challenge and then see where we are with time. Yeah. Yeah. Let's start with roughly 20 minutes. I don't want to leave this, actually I don't want to leave the projector on, it's bad for the bulb, so. Alright, so this number 11 is a prove parallel proof, right? I mean, we're trying to prove 2 lines are parallel. So just a reminder, these are the only 5 ways that we have to prove 2 lines are parallel as a concluding statement. But in order to get to that concluding statement, we have to prove one of these 2 or one of these 5 reasons is true. Okay? So I'll come back to this as needed, but we're trying to prove P and R. So first thing to note is don't make any assumptions that require P and R to be parallel. So we can't do that until we prove they are. But we know that G and H are parallel, so we can use any angles on those that we need to. For example, like 1 and 2, what kind of angles are they on G and H? Those are alternate interior, so they're congruent. So like 1 and 2 are congruent. Okay? Again, I can't jump from 2 to 4 because we don't know P and R yet. But 2 and 3 are a linear pair, so that might come up. And that has nothing to do with P and R being parallel. Okay? So that step that I was just kind of talking through is just translating what we know to the picture, but also starting to make a strategy. Okay. Tells us that angles 1 and 4 are supplementary, which there isn't necessarily a reason for that, meaning that had to be given at this point. Everybody follow that? Okay. Here's one version of the proof. You don't have to do it exactly like this, but most of it should be in your proof at some point in a different order, maybe. Maybe I would say next that angle 1 is congruent to angle 2, and you guys already said that was alternate interior angles. Theorem. Okay, so we have 1 and 2. I already marked it on the picture. So we have some kind of link now between 2 and 4. Do you see that? Because I have 1 and 4 are supplementary, but 1 is 2. Okay? So I can say angle 2 and angle 4, what? Are supplementary. And that's by substitution. Okay? And I've been doing this, so I think I'll just do it again. I did that plugged in right there for the substitution. That's all. Alright, well, in terms of lines P and R, 2 and 4 are a certain type of angle, which is what? Yeah, same side interior. So if we go back to this list, if same side interior angles are supplementary, then the lines are parallel. So check, we just showed that, right? We proved that that was true. So we are ready to conclude P is parallel to R because of what? Awesome. Good job. Done. That isn't the only way you could do this. There are other methods. I think that's the shortest though. Okay? Any others you want to check on? Any others? Any others? What are you guys sharing back there?
Hot fries.
Hot fries? Okay. Are they good?
You want to try one?
No, I'm good. Why is this? Oh. This is the most annoying glitch. When I click on it on the board, it deletes the tab. That is so annoying. Doesn't do that over here. Alright, let's go ahead and check these and see how they went. So 7, there's 7. Angles 2 and 7 are supplementary because of same side exterior angles postulate. So by definition of supplementary angles, they add up to 180. Notice the geometry to algebra shift, right? It's that lines 2 and 3. Number 8. 7 and 5 by corresponding, 5 and 4 by alternate interior, and then 7 and 4 by substitution. Number 9. 1 and 3 by corresponding. We were already told 1 and 2, so we can substitute 2 and 3. And then that's 2 and 3 are alternate exterior, so by the converse of alternate exteriors, those lines are parallel. Any questions on those 3? Just reminding you, I typically do a half point per section or per entry. So this would be like 1, 2, 3, 4, 5 maybe points. That seems a little high for this proof to me, so I would probably drop it back a little. But point is, like, each thing that you write has to be correct, right? Like if you put converse of IAT, that piece is wrong and you would miss a little credit for that. But you're not going to like miss the whole proof. So even if you can get 2/3 of the argument correct, you're still going to do okay on these. Does that make you feel a little better? Okay. Alright, over here. 10. So angles 1 and 2. Then 2 and 3 by corresponding. So we can substitute 1 and 2 and then converse of the corresponding angles theorem. 1 and 2. Something's up with my labels because those are not corresponding. Does it look like what you have?
No.
Okay, so something's weird. What does yours have?
The dot is 3.
Oh, okay. Oh, I know what's wrong. Yeah, so minus points for me. I wrote angles 1 and 2 are congruent twice and it was just given. So I wonder, you're saying the dot was the 3 for you guys? Okay. So yours should probably say angles 1 and 3 are congruent by alternate interior angles.
Yeah.
Okay. Being that 3 is where the dot is. And then we can do substitution to make 3 and 2 congruent, and then converse of alternate interior angles. So I don't know why mine's different there. And then we already checked 11. So fist to 5, how do you feel on just this packet and these kind of proofs? Okay. All right, we're looking pretty good, I think. All right, I'm going to put up kind of an ugly mess problem. You're going to need a blank piece of paper. And where to go? There we go. Your job is to tell me the measure of every labeled angle. This is now review for your